Hello everyone, my name is Matthew Polishchuk, and in this video I'll be going over the MEXT Undergraduate 2016 Math B exam. So I will solve and try to explain every question. And please know that this is part of a series, and in the Math B 2019 video I give a bit of extra helpful info at the start, but to save time I'm just going to go right into the questions for this video. So first is question 1, which says, if log base 3 of 6 minus log base 9 of x is equal to 1 over 2, then x is equal to blank. So for this one, you just need to know a few log rules. The only tricky part about this question, there is one pretty obscure rule that at least I was never taught. So if you never learned it either, then this may be a bit of a difficult question. But once you learn this rule, which I will show now, it becomes quite easy. So one of our logs is in base 3, while the other one is in base 9. The important thing to realize is that 9 is just 3 squared. So if we can remove this being squared, then both of our logs will be in base 3, which means you can work with them a lot easier. And this is where that obscure rule comes in. So if you have a power in the base of your log, like here we have log base a to the power b of x, then you can instead write it as 1 over that power times the log of your base without the power. So log base a to the power b of x becomes 1 over b times log base a of x. So if we use that rule, then what we can do is we can say that log base 3 to the power of 2 of x is just equal to 1 over 2 times log base 3 of x, and then using the regular power rule, we can say this is just log base 3 of the square root of x, right? Because 1 over 2 becomes the exponent to x, and the exponent of 1 over 2 is just the square root. So now we have both of our logs in base 3. With this, we can combine our two logs using the log subtraction rule to get that log base 3 of 6 over the square root of x is equal to 1 over 2. And then if we make both sides as 3 to the power of our terms, then we can get rid of the log on the left side, and the right side becomes the square root of 3. So if we rearrange for the square root of x, and then we square both sides, we get that x is equal to 36 over 3 equal to 12, and that is the answer to this question. And if you're wondering what I did here, this is just another one of the log rules, and definitely one you should know. But basically, first of all, I use just this pretty basic rule, which is that if a equals to b, then c to the power of a is equal to c to the power of b. And then I also use the second rule, which is that if you have a to the power of log base a of b, that is just equal to b. So basically you have a to the power of a log with the same base, then you can just get rid of all that and it just equals to whatever is inside the log. So that's pretty helpful in this question. So next is question 2, which says, if alpha, beta are numbers satisfying 0 is less than alpha is less than pi over 4, and 0 is less than beta is less than pi over 4, and alpha plus beta equal to pi over 4, it follows that tangent alpha plus 1 times tangent beta plus 1 is equal to blank. So for this question, there's a specific trig identity you need to know. In general, you should probably try to memorize a bunch of the trig identities before your exam because they definitely do come up at times. And so for this question, the one you specifically need to know is tangent of a plus b. So I have it right here. Tangent of a plus b is equal to tangent of a plus tangent of b, and all that's over 1 minus tangent of a times tangent of b. So, and if it was instead tangent of a minus b, then you would just switch the signs on the right side. And so if you know that identity, then you can answer this question. So to start, what I did, as you can see, is I expanded the equation that the question gives. So yeah, the question says the tangent of alpha plus 1 times tangent of beta plus 1 is equal to k. So I just expanded it here. And also, k is just the answer. I thought it'd be, a bit more straightforward if I defined what the answer is. So the answer to this question is k. We're looking for k. So, and then next, I use the identity, right? And then I also use the fact that the question says that tangent of alpha plus beta is equal to, that alpha plus beta is equal to pi over 4. Therefore, tangent of alpha plus beta is just equal to tangent of pi over 4, which is just equal to 1. And so that means that, of course, this whole fraction right here that we just found, from the identity, is just equal to 1. And so then, now that we know this equals to 1, I multiply both sides by the denominator to get rid of the fraction. And then I move everything to one side so that this whole thing is equal to 0. And so what you will notice is that the only difference between this equation that we just found here and the previous expanded equation that we found from the question is that in this expanded one, we have +1, and in this new one that we just found, we have -1. Everything else is the same, right? Here we have tangent of alpha plus tangent of beta plus tangent of alpha times tangent of beta. And then here we also have tangent of alpha plus tangent of beta plus tangent of alpha times tangent of beta. And then just here is +1 equals to k, and here is -1 equals to 0. So the way to make this equation exactly the same as the one that the question gives is to just add 2 to both sides. So if we add 2 to both sides, this -1 becomes a +1, right? Because -1 plus 2 is 1. And then this 0 becomes a 2. And so now this equation right here, which by the way, this symbol just means, it's the same thing as over here. This means like, I don't know the exact term, but I use it in school. It just means, repeat what was before. So now we have this equation right here, which is exactly the same as the equation that the question gave us, and it equals to k, which is the answer, which means that it equals to 2, and so the answer to the question is 2. So next is question 3, which says, when x plus y is equal to 2 pi over 3, x is greater than or equal to 0, and y is greater than or equal to 0, the maximum of sine x plus sine y is blank, and the minimum of that is blank. So for this question, you need to be able to analyze trig functions and the special common angles, and you also need to be able to find the derivative of a trig function in order to find a minimum or maximum. You also need to know a specific trig identity, specifically sine A plus B. So here's that identity if you didn't know it. Sine of A plus minus B is equal to sine of A times cosine of B plus minus cosine of A times sine of B. So anyways, firstly, for our question, we need to check the bounds of our range, which is something that you always do for a question like this where you're looking for the maximum and minimum of a function. I explained why that is in my Math B 2019 video, which has a question very similar to this one. To save time, I won't explain it again in this video, so if you're not sure why I'm checking the bounds, be sure to watch my Math B 2019 video. But anyways, the question says that both x and y are greater than or equal to 0. So the bounds we can check are when x is equal to 0 and when y is equal to 0. So first let's do when x is equal to 0, which means that y is equal to 2 pi over 3. We get sine of 0 plus sine of 2 pi over 3, which is equal to 0 plus the square root of 3 over 2, which of course is just equal to the square root of 3 over 2. And in case you're wondering, I use this special triangle over here to help remember the values of trig functions with these angles. Okay, then let's check the other bound, which is when y is equal to 0. In that case, x equals to 2 pi over 3, and you'll notice that this is just the exact same equation as the one we saw here, and we get the square root of 3 over 2 again. So now in order to check for any possible maximum or minimums within the range, we want to find the derivative of our expression, sine x plus sine y. So to start, we need to write everything in terms of one variable. So I wrote y in terms of x like this. And now our expression looks like this, sine x plus sine of 2 pi over 3 minus x. So this is where the identity that I mentioned earlier comes into play. Anyway, so if you use that identity, you'll get this. I won't explain like all these steps because it's just some pretty simple trigonometry. But of course, you can pause the video if you want to look at my steps. But we end up with this, 3 over 2 times sine of x plus the square root of 3 over 2 times cosine of x. So now we need to find the derivative of this function, which is pretty straightforward. It's just some basic trig derivative rules. And so if we set the derivative equal to 0, then we can find a possible minimum or maximum. So to do that, we rearrange our equation a little here. And we find that, we rearrange this a little bit, and we get that the square root of 3 times cosine of x is equal to sine of x. So here you just need to be able to recognize that this corresponds to the special common angles. So if you look at the triangle I drew here, it specifically corresponds to pi over 3, since sine of pi over 3 is equal to the square root of 3 over 2, while cosine of pi over 3 is just equal to 1 over 2. And so that would make the two sides of this equation equal to each other. And so that would mean that x must be pi over 3. So that means at this value of x, there is a possible minimum or maximum in our function. So now let's try pi over 3 for x. So first, we use this value to find y, which is also just pi over 3. Then we plug these values in. We find sine of pi over 3 plus sine of pi over 3, which is equal to 2 times the square root of 3 over 2, which is just equal to the square root of 3. So previously, when we checked our bounds, we found that both of them just equal to the square root of 3 over 2, the square root of 3 over 2. And now we found that when the tangent is equal to 0, our function equals to the square root of 3. So that means that our minimum is equal to the square root of 3 over 2, and the maximum is equal to the square root of 3, and that is the answer to this question. Also, you may be wondering why when I found x with the derivative, I didn't check any other possible values of x, right? Since this is a trig equation, there are more possible values of x that would make square root of 3 times cosine of x equal to sine of x true. But our question says that x plus y equals to 2 pi over 3, and both x and y are greater than or equal to 0. Now the next possible value of x that would solve this equation would be 4 pi over 3, but if we use that x value, then there would be no possible y value based on the restrictions given in the question. So pi over 3 is the only possible value of x for this. So next is question 4, which says, on the basis of the premises and the conclusions 1, 2, 3 below, fill in the left-hand blanks with 1 if the corresponding conclusion is logically derived from the premises, and with 0 if it is not. There are several 3-digit numbers n, m, l, each digit of which is either 1 or 2. There are some numbers with n equals 1 and other numbers with n equals 2. If n equals 2, then n equals 2. And if l equals 1, then n equals 2. The first premise, first I'll just say, this is a pretty interesting question, and there isn't anything specific you need to know to answer this one. You just need to use a little bit of logic. So to start, it suggests that if n equals to 1, then m must equal to 1. So firstly, let's see if it's even possible for n and m to equal to 1. If n equals to 1, then there is no specific restriction on what m can equal to. So it is definitely possible to get a number where n and m equal to 1. Next, let's consider the counter to the statement the question gives, which would be that n equals to 1 and m equals to 2. So the question says that if m equals to 2, then n equals to 2. That means that we cannot have a number where n equals to 1 and m equals to 2. Since once we make m equal to 2, n has to equal to 2. Therefore, this possibility where n equals to 1 and m equals to 2 cannot be possible. And so logically, that means that if n equals to 1, then m must be equal to 1. And so our first conclusion is true. The next part says that there are no numbers with m equals to 1 and n equals to 2. Well, the premise says nothing about what happens when m is equal to 1. It only gives rules for when m is equal to 2. So that means that when m is equal to 1, n can be whatever it wants. So there definitely are numbers with m equals to 1 and n equals to 2. So the second conclusion is false. Finally, the last part says that there are no numbers with m equals to 1 and l equals to 1. So the question says that when l equals to 1, n must then be equal to 2. But as we talked about in the last section, when n is equal to 2, m can equal to 1. So there definitely are numbers with m equals to 1 and l equals to 1. And so the third conclusion is false, and those are the answers to this question. So next is question 5, which says, consider the following diagram that consists of vertices and edges. Crosses are pairs of edges whose crossing points are not vertices. Suppose that one can move from one vertex to another if, and only if, the two vertices are connected by a unique common edge. The number of routes that one can take from the leftmost vertex L through 6 edges and 5 intermediate vertices to the rightmost vertex R is blank. So again, like the last question, this one doesn't require any specific knowledge. You have to use a bit of logic. The first important thing to notice is that based on the restrictions given, you can only ever move to the right because you can only ever move through 6 edges and 5 vertices. So let's just choose a random path through this and count the number of edges. So from left, let's go, 1, 2, 3, 4, 5, 6. So we pass through 6 edges. And if you count the intermediate vertices, which means the vertices other than the ones at the very start and very end, then there are 1, 2, 3, 4, 5. So you can only ever go to the right. If you try to go backwards, you'll pass through too many edges and too many vertices. So for example, let's try following a different path and count all the edges. So let's go, 1, 2, 3. So let's go backwards here. 4, 5, 6, 7, 8. So that's too many edges. So that doesn't work, which means we can only go from the left to the right. So now that we know that, it gets a lot easier to find all of the paths. And let me quickly erase these marks. Okay. So the method that I use is something like this right here. I basically draw a network of branching paths based on branches in the given structure, and at the end I add up all the possible paths. So this is just a part of the tree I'll make as an example. There might be other ways of doing this, but this seems like the easiest method to me. So let me give an example of what I mean. Let's start at the first vertex right here. You'll see I have 2 possible paths from here. I can either take the upper path or I can take the lower path. So I'll start by taking the lower path. So like this. And so I will draw on my tree the corresponding branch that goes down. And these other branches are the ones from when I went up before. So now when I take the lower path, I have 3 options. I can go up, I can go middle, or I can go down. So let's draw all 3 possibilities as branches. So the upper branch, the middle branch, and the lower branch. And I guess let's try to make them all, about the same length. So let's see what happens when I go up. So now I only have 1 possible path, which is like this. So I'll just draw that 1 possible path. And also, I guess you might want to make your triangle or your tree a bit bigger so your branches don't get in the way of each other. But it's not a big deal. I'll just bend this branch a little bit. So I draw 1, and then anyways, so yeah, there's 1 possible path, and then once I'm here, there's again only 1 possible path, so I just draw that 1 path. And so finally here, at this point, I have 2 possible paths. I can go upper or lower. So I'll draw 2 branches. And then each of these 2 branches only have 1 possible way to the end, right? If I'm here, I could only go this way, and if I'm here, I can only go this way. So each of these branches have just 1 path left each, and so these are now concluded, and that's 2 more paths. So I already found 5 earlier. I just found 2 more, and so if you were to draw the entire network like this of all the paths, you'd find that there are 12 paths total, and that is the answer to this question. I'm not going to spend time finding all the paths because I feel like once I showed you guys 1 example, it's pretty straightforward how to find the rest. So I will leave it as an exercise to the viewer to find the entire tree with all 12 paths. So next is the section 2 question, which says, let R be a positive constant. Consider the cylinder x squared plus y squared is less than or equal to r squared, and let C be the part of the cylinder that satisfies Z is less than or equal to Z is less than or equal to Y. Fill in the blanks with the answers to the following questions. So to start, I just want to say that this is a very hard question, at least in my opinion. I had no idea how to even begin to answer this question for a really long time. And I really have no idea how a high schooler can be expected to answer it. Maybe in other parts of the world they teach 3D geometry like this, so it might not be that difficult for you. But in general, I definitely think you should not feel bad if you can't answer this question. But anyways, let's start. So firstly, you should just draw the cylinder that they're asking about. So we have x squared plus y squared is less than or equal to r squared, which is the circular base of our cylinder right here. And if you're wondering why it's less than or equal to r squared, instead of just r squared, it just means that actually this entire cylinder is filled in like this. So normally if you have, say, the unit circle, it's just the perimeter, so it only equals to x squared plus y squared. But our shape also has the entire inside filled in, which is why it's less than or equals to. So to start, we have the cylinder. Then it also says that 0 is less than or equal to z, which is less than or equal to y. Let's focus first on the fact that it says that 0 is less than or equal to y. So that of course means that y is positive. So if this is our y-axis, right, going into and out of the page, and let's say, the direction towards us is positive, then that means that the other direction is negative. So because y is greater than 0, that means we only consider the positive part of the cylinder. So we actually only have this half of the cylinder in our shape. So yeah, I've drawn here one half of the cylinder. Now let's consider the part where it says that 0 is less than or equal to z specifically, which is less than or equal to y. So z is the vertical part, or the height of our cylinder, and it must be less than or equal to y. So, and y is this direction, of course, going in and out of the page. So this direction is along the y-axis. Sorry, 1 second, okay. Yeah. So, let's say, for instance, that at this point right here, our y is equal to 1. That means that at this spot, the height of our shape is also only equal to 1, because z is at most equal to y. So here at this point, our z would be equal to 1. So what you can realize is that if we were to rotate our cylinder like this, so that now we're looking at it from the side, our shape looks something like this. So our base is half of a circle, and then you can say that our, the roof of our cylinder is slanted like this. And the height of this roof at any point is equal to the y value at that point. So for example, if we said that, this point right here, like at the middle of this, and this is at the base, this point is at the base. Let's say at this point is a distance of 2 in the y direction, right? Because y is our left to right axis. So this is a distance of 2. That means at this point right here along this slope, at this point right here, the height, or the z value, is also equal to 2. So hopefully that makes sense and you can understand what this shape that we're working with looks like. So now I can think about the first part of the question, which says, it says, consider the cross-section of C by the plane x is equal to t. Negative r is less than or equal to t is less than or equal to r, and express its area in terms of r and t. So firstly, what is this plane t? Well, what it's saying is that we choose an x value, and at that x value, we cut our shape. So I tried drawing the plane for both of these perspectives here, so you can see what it means. So let's say, for example, that t is equal to 2. So that means that the point at which we cut our shape is 2 units away from the origin in the x direction. So if this right here is our origin, then right around, say here would be 2 units away in the x direction. And so our shape would be cut right along here. So it would be cut like that, and also like that. And so that would be, that would be the cross section that we're looking at. And then another way to look at it, so in this case, if we're looking at this one right here, so this would be our origin. And then let's say it would be this point right here would be our x. And so the shape that we are looking at would go, our plane would cut through our shape like this. And so the reason why the y is between negative r and r, or sorry, t is between negative r and r, is because, if we look at our cylinder here, these points at the edge of our cylinder are exactly a distance of r away from the origin, right? Because, this cylinder is just our circle, and the circle has a radius of r. So this point right here is a distance of r away from our origin. And so if we were to make t greater than r, if we were to make our plane, further away than r, then it wouldn't cut through anything, right? Because there'd be no cylinder left, because it would be past the distance of our cylinder. So hopefully that makes sense, and hopefully now you can understand what this plane is, what we're talking about. And so we need to find the area of the cross section of our shape and of the plane. So yeah, let's say once again that our plane is, right here along this R. So what you may notice is that the cross section is just a right angle triangle, actually, because the thing is our base is, this length right here from the edge of our circle up to this other edge. And then our height is just up to, up to that part of the roof. And then this side is just a straight angle, or a straight line, I mean, because this plane is just completely vertical. And, remember, we also determined before that the height of the cylinder at a point is equal to that point's distance away from the y-axis. So that means that the base and the height of our triangle are the same, and they're just equal to whatever the y value is at the edge of that part of the cylinder. So we can look at just the triangle here. So at this point is where y equals to 0, and that's equivalent to, along this edge right here. At this point, this is the edge of our circular base, and that's, so that would be like, let's say if our point that we're looking at is here, then the edge of our circular base would be like right over there. And then our height is just equal to y, right? Because we determined that, if our y value here is, let's say, let's just say this is a distance of, 3 away in the y direction, then this point would have a height of 3. And so you put those together and you just have a right angled triangle like that. And sorry, my diagram is getting a bit messy. Unfortunately, like I said, this is a really hard question, and I really don't understand how you do this, on a test with paper, especially with the time limit. Because, you could, by the way, this could be helpful if you're finding it hard to follow along. What you could do is you can, for instance, ask ChatGPT to give you code that would visualize this shape. And you can look at that and maybe then it would make more sense. But the problem is, and why I'm not doing that for you guys right now, is when you're actually writing the exam, you obviously don't have the ability to, pull up a computer and ask it to make a 3D model for you. So if I'm trying to get you ready for this exam, then that's kind of, it doesn't make sense for me to do that, right? Because that won't actually get you ready for the exam. For the exam, you have to be able to draw by hand like I am right now. But if this is getting hard for you, then you could just, take a screenshot of the picture, put in ChatGPT, ask it to make you some code in Python, and then ask it how you can run that code. And then you can have a 3D visualization of what this shape actually looks like. And hopefully that could help you if right now my explanation isn't enough. And honestly, my explanation probably is enough because, like I said, this is a hard question and I've never done this topic before, and I'm trying my best. But yeah, anyways, so now, sorry, I kind of lost where we were. 1 second. Okay, so yeah, so we determined that the cross section is just this right angle triangle, right? And so the area of it is, and so obviously the area of a triangle is 1/2 times the base times the height. And we determined that our base and our height are the same, right? Because the z value over here is just the same as the y value. So the area of our triangle is 1/2 times this y value at the edge squared. And so the question is, how do we find this y value at the edge? So what we can do is we can use the equations that are given to us in this question. So we have that x squared plus y squared is less than or equal to r squared. And we also have that x equals to t. And so we can get that t squared plus y squared is less than or equal to r squared. Rearrange a little, we get that y squared is less than or equal to r squared minus t squared. And then if we square root both sides, we get that the absolute value of y is less than or equal to the absolute value of the square root of r squared minus t squared. Or put another way, we have that the value of y is between negative of this square root and positive of this square root. But of course, the question also says that, y is greater than or equal to 0. So actually the bounds of our y is, it's between 0 and this positive square root. And remember, the reason why it's less than or equal to is because we're talking about this entire, cylinder, and the entire part of the cylinder is filled in, which is why it's not just equals to, but less than or equal to. If it was just equals to, then we would only have like the outside, like the surface of our cylinder, but we have less than or equals to here because we're talking about this entire filled in 3D object. But since we just want the base and height of our cross section, we can just say that y is equal to this square root. And so that means also that z is equal to this square root. So using the formula for the area of a triangle, we have 1 over 2 times the base times the height, which are equal to each other. So it's just 1 over 2 times the base squared, which means our area is 1 over 2 times r squared minus t squared. And that is the answer to the first part of the question. And here is, a little diagram just to reiterate what we're looking for here. So we have our half circle base here in green, and we want to find the cross section of the shape and a plane at a certain value of x. So these dashed lines are the outline of our shape along that plane. Along this edge, so this edge over here, both y and z are equal to 0. And at the edge of our shape along our cross section, right here, our y value is equal to this square root, which we just calculated. And at the z value above that point, it has the same value as a y value. So our cross section is this right angle triangle, the base is this square root, and the height is also this square root. And that's how we get this area. So next, it wants us to find the volume of this entire shape. So we already found how to get the cross-sectional area for any plane. Now let's say you found the area for, this plane right here in red, and you also found the area for, this plane, and I also draw a triangle just to see so you can see what I'm talking about. And we also found the area for this plane and for this plane and so on. We found the area for all of these planes. And if you started to sum up all these areas, then you can find the volume of this entire shape. So hopefully you can see where I'm going with this. What we want to do is use an integral to find this volume. So we are looking for the integral of the cross-sectional area of our shape. Remember that r is a constant that's given in the question, and so our integral is with respect to t. So the question now is, what are the bounds of our integral? Well, let's consider this small drawing of our shape right here. This point right here is our origin. And, sorry. So our x, y, and z are all 0 over here. And at this point, say over here, our x value is just equal to r, right? Because this base is a circle and our circle has a radius of r. So at the very edge of the circle over here, our x value is equal to r. And so clearly there's no reason to take an integral beyond r, because since past that point, there's no shape to even consider. And likewise in this direction, our x is just equal to negative r, and so there's no reason to take our integral beyond negative r as well. So the bounds of our integral are between r and negative r. Also, what you'll notice is that at x equals to 0, the two halves of our shape are completely set, right? So x is equal to 0 right here, and then the volume of the shape, above this part, or not above, but like into the page, is same as the volume of this part going out of the page, right? It's symmetrical along that axis. So what we could do is we could just do the integral from r to 0 and multiply it by 2. And so that 2 cancels out this 1 over 2. So we just have this integral of r squared minus t squared dt from r to 0. This is just a simple power rule. And we find that the volume of our shape is equal to 2 over 3 times r cubed, and that is the answer to this part of the question. Okay, so next it asks, let A be the length of the arc along the base of circle C from the point r 0, 0 to the point r cosine theta, r sine theta 0. And 0 is less than or equal to theta is less than or equal to pi. Let B be the length of the line segment, from the point r cosine theta, r sine theta 0 to the point r cosine theta, r sine theta, r sine theta. express A and B in terms of r and theta. So, let's draw what it says, which I see I already did here. We have our shape, or at least we have the base of our shape. Hopefully you guys can at this point visualize what the rest of the shape would look like if I drew it. Just didn't draw it here because it would get pretty messy. And so right here is our origin, right? And here is the point R00, which is one of the points given to us in the question. So it's right at the edge of our shape, and it's along the y and z axes. So, or I guess the y and z planes would be a better way to put it. So then we have this point right here, r cosine theta, r sine theta 0. So what you notice is, this is basically just a definition of a circle in terms of theta. So our angle in here is theta. And then the distance in the x direction is just r times cosine theta, and the distance in the y direction is just r times sine theta. So you're probably used to seeing this, whenever you use the unit circle, for instance. And so A is asking us for the length of this arc from r00 to this point r cosine theta, r sine theta 0. So this is just a general formula. The length of an arc is just equal to r times theta. And so for this question, A is equal to r times theta. Next, you'll notice that, this other point that they give us, r cosine theta, r sine theta, r sine theta, is just at the same point as, or just at the same place as this point right here, but a distance of r sine theta above it. And this distance right here is the B that we're looking for in the question, right? They're asking us to find the length of the line segment from the point r cosine theta, r sine theta 0, which is right here, to the point r cosine theta, r sine theta, r sine theta, which is right up here. And so, right, the length of this is clearly just r sine theta, and so B is equal to r sine theta, and that is the answer to this part of the question. Okay, and finally, the question asks us to find the area of the side of C with x squared plus y squared equals to r squared, or in other words, find the surface area of the outside of our shape. Okay, so it's this striped part over here. That is, we're trying to find this surface area here along the outside of our cylinder. So now the way you find this is really, well, I guess weird. And by weird, I just mean that, at least in my case, it's a method for finding integrals that I didn't even learn about until I was in my second semester of engineering at university. So, if you did manage to get this far and you couldn't do this last part, definitely don't feel bad. As, I really have no idea how a high schooler would be expected to answer this. Again, maybe in other countries, this is a normal part of the curriculum, but at least where I'm from, this is kind of crazy. But anyways, you want to find the surface area. And what we're going to do is we're going to break this surface up into tiny little rectangles. And then if we find the sum of those tiny little rectangles, we'll find the entire surface area. So the height of our rectangle will be r sine theta, which is what we found here, right? The height at any point along the edge of the circle is just r sine theta, which again, we determined before, right? If the y value is r sine theta, then the z value will also be r sine theta. So that is the height of our rectangle. And the width of each rectangle is r times d theta, meaning an infinitely small rectangle. So you're probably used to seeing, dx, for instance, in an integral, and that's saying an infinitely small width of x. In this case, we're doing d theta, which means an infinitely small angle. So hopefully you can see what's going on here. This is an integral similar to the ones you're probably already used to if you've done a first calculus course, or you learned about integrals and derivatives in high school, where what you do is you use infinitely small rectangles to find the area under a curve. And this is pretty much the same thing. Our curve is this, upper outline of the shape, this line here in red. And I guess the only part that is weird is that instead of using dx, meaning rectangles with infinitely small widths in the x direction, we're using r times d theta, meaning rectangles whose widths are an infinitely small angle. And the reason why it's r times d theta is because the formula for the length of an arc is r times theta, which is, of course, what we use to find a right here. A is equal to r times theta. R times theta is just the length of the arc. And so we have r times d theta being an infinitely small angle on our arc. So yeah, definitely not something I learned to do in high school, but hopefully that makes sense. So our area is the integral of the height of our small rectangles, which is r sine theta, times the width of our small rectangles, which is r times d theta. So combine the r's and you get the integral of r squared times sine theta d theta. And the next question is, what are our bounds? Well, we're using angles, and we have a half circle. So at this point right here, our angle is just 0, right? Theta is equal to 0. And at this point right here, an entire half circle away, our angle is, of course, equal to pi, right? Because pi is half a circle. So our bounds, that means, are from 0 to pi. And also, because this is an integral in terms of theta, our r is just a constant, so we can take it out. So then, this is just a basic integral of sine theta. So we get negative cosine theta from pi to 0, plug those values in, and you end up with r squared times 1 plus 1, which is equal to 2r squared. And that is the final answer to this very crazy question. So lastly, we have section 3, which says, let a be a number with a does not equal to 0, and it's between -1 and 1, and b an arbitrary real number. Let f of x equal to ax plus b. Moreover, let f1 of x equal to f of x, and fn of x equal to f of fn minus 1 of x, n is equal to 2, 3, 4, so on. Fill in the blanks with the answers to the following questions. Express fn of x, n is equal to 1, 2, 3, so on, in terms of a, b, x, and n. So for this question, you need to know what the sum of a geometric series is. So if you have a sum that looks like this, a plus ar squared plus ar cubed, so on until ar to the power of n, then the sum of that is equal to a times 1 minus r to the power of n divided by 1 minus r. So if you know that, then you can try to answer this question. So to start, let's just check the first few values for n. So f1 of x is just ax plus b. f2 of x is f of f1 of x. So we take f1 of x and replace the x with ax plus b. And so if we expand, we get that f2 of x is equal to a squared x plus ab plus b. Next, let's check f3 of x, which is just f of f2 of x. So we take f2 of x, which we just found, and replace the x with ax plus b. And then if we expand that, we get a cubed x plus a squared b plus ab plus b. So perhaps you can already see the pattern here, but just in case, let's check f4 of x as well. So after, once again plugging in and expanding the same way as before, we see that it equals to a to the power of 4 times x plus a cubed b plus a squared b plus ab plus b. So hopefully you can see the pattern here. So this first term with x is just a multiplied, or a to the power of n multiplied by x. And then the rest of these terms are just that geometric series that I talked about earlier. So that means that we can express fn of x like this. A to the power of n times x plus a b times 1 minus a to the power of n divided by 1 minus a. And that is the answer to the first part of the question. So next is part 2, which says express fn of x minus fn minus 1 of x divided by a to the power of n is equal to 2, 3, 4, so on, in terms of a, b, x, and n. So first, let's just try to find what fn minus 1 of x is. So take fn of x, which of course we just found, and just subtract 1 from n, and we get this. And now let's try to find the denominator of the expression given in the question, which is fn of x minus fn minus 1 of x. So if we write it out, it looks like this. First thing we can do is we can group some like terms. So both of these terms have x, so we can then just group them like this with x. And then both of these terms have b, so we can group them with b like this. And then you'll see how this plus 1 and this minus 1 cancel out, so we can ignore those. And then what we can do is we can factor out a to the power of n minus 1 from both of these terms. So now this becomes a to the power of n minus 1 times a minus 1 times x, and this becomes b times a to the power of n minus 1 times 1 minus a over 1 minus a, and these of course cancel out. Now, if you're wondering how I did this factoring, I made an example right here. So we have a to the power of n and a to the power of n minus 1. Now let's say, for example, that n is equal to 5. So now I have a to the power of 5 and a to the power of 5 minus 1, which is a to the power of 4. Oh, sorry, this says equals to 4. That should say equals to a to the power of 4. So if we take a to the power of 5 and divide it by a to the power of 4, then it equals to a, right? Because these 4 a terms cancel out with 4 of the a terms in a to the 5, and you're just left with a single a term. And then, of course, a to the power of 4 divided by a to the power of 4 is just equal to 1. So, more generally, we have that a to the power of n divided by a to the power of n minus 1 is equal to a, and a to the power of n minus 1 divided by a to the power of n minus 1 is, of course, just equal to 1. So, once we know that, we can go back to our question. So we can factor out a to the power of n minus 1 from both of these terms, right? This a to the power of n just becomes a, while this a to the power of n minus 1 just becomes 1. And then on this side, we factor out a to the power of n minus 1. So this a to the power of n minus 1 just becomes a, this a to the power of, just becomes 1, and this a to the power of n just becomes a. And that's how we get this expression right here. And then because both of these have a to the power of n minus 1 factored out, we can group the terms, and we have a to the power of n minus 1 times a minus 1 times x plus b, and that is equal to fn of x minus fn minus 1 of x. So we found the numerator of the expression that the question asks about. So now we can try dividing this by a to the power of n minus 1, a to the power of n, like the question asks. So it looks something like this. And once again, here we can cancel out a to the power of n minus 1 from the numerator and the denominator, right? So this a to the power of n minus 1 is canceled out completely, while this a to the power of n just becomes a. And so we are left with a minus 1 times x plus b divided by a, and that is the answer to the second part of the question. So next is part 3, which says, consider the curve y equals to fn of x minus fn minus 1 of x divided by an, and the line y equals ax plus b. Find the intersection point Q of the curve and the line above, and express xn, yn in terms of a, b, and n. So we want our curve to intersect with the line, which means we want our curve and the line to equal to each other. And of course, that curve we just found. So we just take what we just found and make it equal to the line, which the question says is just ax plus b. So once we have this, all we need to do is rearrange for x. I'm not going to go through every step because it's some pretty basic algebra, but of course you can pause the video if you want to look at it closely. But anyways, once we rearrange for x, you'll see that it equals to b times 1 minus a over a squared minus a plus 1. And that is the first part of the answer to this question. So now we need to solve for the y value. And to do that, we're just going to take the equation of the line, and we're going to sub in this x value that we just found for the x value in our line. So the line is ax plus b, and we take this x value that we just found and sub it in. And then once again, this is just some expanding here. What you'll notice is if you take this b term right here and you make it part of the fraction by multiplying it by a squared minus a1 plus 1 and also dividing it by a squared minus a plus 1. So if you do that and turn this into one fraction, you'll see a lot of these terms cancel out. So we have ab and minus ab, we have a squared b and minus a squared b. So the numerator is just left with b. And so our y value is just equal to b over a squared minus a plus 1. And that is the answer to this part of the question. So we have our x value of the intersection point, and we also have our y value of the intersection point. So finally is part 4 of the question, which says, calculate the limit as n approaches infinity of fn of x and express it in terms of a, b, and x. So you've probably seen limits before if you've taken a calculus class, Basically what this is saying is that n equals to infinity. Now, technically it doesn't, and the reason why this limit here is because n cannot actually equal to infinity, since infinity isn't a number. So what this limit is saying is that our n value is approaching an infinitely large number. But if that doesn't make sense to you, then you can just plug in infinity for n and technically get the right answer. If this was an exam where they look at your mark, you definitely would lose marks for that. It's not correct to say that n just equals to infinity. But on this exam, as far as I'm aware, they only care about the final answer, so it's acceptable here. So anyways, we want to find the limit as n approaches infinity of fn of x. We already found fn of x in part 1. It equals to, a to the power of n times x plus b times a to the power of n minus 1 over a minus 1. So what happens when n approaches infinity here? Well, if we look at the very start of our question, it says that a is between -1 and 1, and it also doesn't equal to 0. So put another way, the absolute value of a is less than 1. And in that case, the limit as n approaches infinity of a to the power of n is just equal to 0. So if that doesn't make sense to you, I can show you an example. So let's say that our value of a is 0.9, which is of course less than 1. So then a squared is 0.9 times 0.9, which equals to 0.81, which is of course less than 0.9. And then to find a cubed, we just multiply that by 0.9 again, which is equal to 0.729, which is even smaller. And then for the fourth power, we take that, multiply it by 0.9 again, and we get 0.6561, which is smaller still. So as you can see, as the power increases, our number gets smaller and smaller. So when the exponent is infinity, or more accurately, when the exponent approaches infinity, this will just equal to 0. Since each time you increase the exponent, you're multiplying by a number that is less than 1, in this case 0.9. So your answer will get smaller and smaller, and it will approach 0 as the exponent approaches infinity. So going back to our question, because a to the power of n becomes 0, we have right here 0 times x, which of course just removes that term completely since we're multiplying by 0. And this a to the power of n right here also just becomes 0. And so this just equals to -b over a minus 1, and that is the answer to this final part of the question. Also, if you're wondering why some of my answers look a little bit different than the answer provided by the answer key, it's because in those answers, they multiplied both the numerator and the denominator by -1. That, of course, doesn't change the value since you're multiplying both the numerator and the denominator by the same thing. So they are the same answers, they're just written a little bit differently. So that is it for this exam. I hope you found this helpful. If you have any questions about this exam, leave a comment and I will try to help you if possible. And if you're writing the MEXT exam soon, then good luck and have a good day.